Hello there. This is just a quick introduction to Venn diagrams and how they can be used to solve probability problems. So let's say there are two events, event A and event B. They can be represented by circles. Now anything that falls outside of these events will go outside these circles over here in this space. Now if event A happens on its own, you have to think of this space over here to the left. If event B happens on its own, you have to think of this space over here to the right. If both these events happen, then you have to think of this space over here in the middle, where both these circles intersect. Now if none of these events happen, then you have to think of the space outside of these circles over here. So when you have two events, this is how you would use a Venn diagram. Now with probabilities, if it's certain that something isn't going to happen, then you assign the value 0 to it. If it's certain that it is going to happen, then you assign the value 1 to it. Now all the probabilities in between lie between 0 and 1. So for instance, if you flip a coin, you can either get heads or tails. The probability of getting heads is 50%, and the probability of getting tails is also 50%. So you would assign the value 0.5 to flipping for heads, and you would assign the value 0.5 for flipping for tails. So as you can see, possibilities lie on this spectrum between 0 and 1. With Venn diagrams, these rectangles are called sample spaces, and the letter S represents the sample space. Now the sample space will always be equal to 1. That means that this part of this circle over here, plus the part in this center, plus the part to the right, plus the part outside of these circles, combined will be equal to 1. As one example, we can go back to flipping a coin. The possibility of getting A is 50%. The possibility of getting B is also 50%. The possibility of getting neither would be 0, and the possibility of getting both at the same time would also be 0, technically speaking. So this part of this circle over here would have the value 0.5. This part would have the value 0. This part of this circle over here would have the value 0.5. And this part outside of the circles would have the value 0. So combined, all these spaces would be equal to 1. So that's just one example of how to use a Venn diagram. But obviously in this case, the intersection over here would be equal to 0, because when you are flipping a coin, you can't really get heads and tails at the same time when that coin lands. Okay, now moving on. We can have the kind of event A intersection B. That just means that both events have happened simultaneously, and that's represented by the intersection on the Venn diagram. So when there is an overlap between event A and event B, we write A intersection B. This represents A intersection B. Here event A and B both occur. So like I said, that's going to be represented by the intersection over here. to the next kind of event, we can have event A union B. Okay, well, that is the possibility of A happening on its own, B happening on its own, or both A and B taking place simultaneously. So, like I said, this type of event can be written as A union B. It represents the event that either A or B occurs, or that both occur. Alright? Now for the final event in the introduction, that is the event not A. Okay? So this is the event A not taking place at all. And that includes A and B not happening simultaneously. Okay? So, I'll explain this more clearly. This is the event not A. It represents the event A not occurring. Since the sample space is always equal to 1, the equation for this event is 1 minus the probability of event A taking place. Okay? So the probability of not A is equal to 1 minus the probability of A. And in this Venn diagram, the part outside of the circle A is going to be shaded. Okay? And that represents the event not A. We can have something similar for the event not B. So the part outside of the circle B would be shaded in the event of the event not B. Alright? Now this equation over here can be transformed to get the possibility of event A. So if we add the possibility of A to both sides of this equation, we get the possibility of not A plus the possibility of A is equal to 1. If we subtract the possibility of not A from both sides of this equation, we end up with the probability of A is equal to 1 minus the probability of not A. Okay, so this equation over here can be flipped so that you can get the probability of the event A taking place. Alright, so that is the introduction to Venn diagrams covered. If you have any questions, leave them in the comment section. If this video has been useful to you, make sure you are subscribed to this channel for more similar content. Thanks for watching this clip, and I'll see you in my next video.